Hello, so we have sort of gone over to RStudio, and this should look pretty familiar to you if you went through our introductory videos. Um, Again, if you have not watched those, definitely hop over to the website and sort of go through them. They're relatively short. But just so we quickly have our sort of orientation here in RStudio, up in the top right is our environment. So that's where our preloaded data sets are located, as well as our variables, which is referenced as values. If you are brand new to R or don't use it very frequently, or keep your environment relatively clean, this should be empty for you. So don't be concerned about that. Down here we have our files that are in our current working directory, plots, so when you end up plotting something, it'll pop up down here, packages, which will come back to you in a little bit, but packages are essentially just bits of code that are written to make a job more easily or easier to do. Again, Tidyverse is made up of many packages, so we're going to install all those packages and then load them in as we need them. And then we have our traditional help viewer and presentation, which we will not really be engaging with today, potentially help if we need to. Down in the bottom left is our console, and then in the top left is sort of a mix between R scripts. So there was a video introducing that. So this is an example of an R script right here that we'll be working with a little bit today. And again, this is sort of like a Word document where you can write your code and then comment out text that isn't code, but it's just one way to interact with it. Then what I'm using over here, this .rmd, is an R markdown file, and it's sort of like typesetting in this language. So if anyone's familiar with things like LaTeX, it is similar to that, except the main difference is you can actually run bits of code. So each of these cells here are specifically set up to run our code. So you can go ahead and click the plus button when you want to run that code, and everything else will not be executed. So this is just literally like a Word document. And so the output of this is going to be in HTML, but you can output it into PDFs and things along those lines. This is a great way to sort of engage with material for classes and things along those lines. So definitely look up R Markdown files if you're unfamiliar with those. But really all you need to know when you interact with this is just hit the little plus button here, and that will run it. I guess the only other thing that you need to know is that when you're engaging with R Markdowns and you say install a package or save a variable or something along those lines, they're only defined within the cell. And so when you're actually installing the package, you might want to do everything in console, or you might want to do everything in an R script over here. So when I install this, you might want to, again, take this code and then copy and paste it into your console and then run it. Great. But let's get into it. So installing packages is relatively easy, and Tidyverse is particularly easy because all of the packages that you need are united into this one thing called Tidyverse. So Tidyverse itself, as we mentioned, is not a package, but it is a collection of packages. So we're going to use this command, install.packages, in little quotes here rather. We're going to write Tidyverse all lowercase, and then we're all good to run that. And so basically, this is not going to I do not want to do that. But what you're going to do is essentially just run the line and let it install. And you're going to get this text right here, where essentially it's going to say trying a URL. This is its location on CRAN. And then it's going to say that it's successfully downloaded here. If you get an error here, reach out to the Slack and we can help you walk through it. I get this little error here because it's already a loaded package, but for you that will not be an issue when you run it. And then what we need to do is just sort of load the library for the Tidyverse. And so the way we load a library is just by typing the actual word library and then the name of the package or the collection of packages inside. And so again, because Tidyverse is a collection, we're going to load a whole bunch of different packages, including ggplot2, Tibble, Tidier, Reader, Per, Doppler or dplyr, stringer, and forecast. So we can go ahead and hit run, and we've gone ahead and loaded our Tidyverse. Great. Now, just as a note, if you only want to sort of load one of these packages at a time, you're able to do so. So they're still sort of located in your R environment. And there's two ways to do this. So you can either just type, library, Tibble, and tidyr, or you can find them in your packages tab down here. So again, by clicking on packages and then bringing this up, and you could just search for them. So Tibble is right here. And if we wanted to do tidyr, it's right here, and you just need to click the little checkbox, and then it will load it for you. Great. So one thing to mention, I know we didn't talk a lot about FAIR, but it's this idea of just making sure our data are reusable across contexts, institutions, etc. So one way you could really do this, at least in the most trivial sense, is to stay within the Tidyverse. And so that's, engaging with these different packages up here. But it's, difficult to do this in practice, basically. And so, a lot of disciplines have very highly specific aims. And so they have highly specific packages. And so bioinformatics is a good example of that, where, there's extra things that are outside of the Tidyverse. But we can try to, try to stay within sort of the common grammar, common philosophy of Tidyverse to make it easier for ourselves and others, even though we have to go outside of the Tidyverse. And so again, just to reinforce, the reason we even care about Tidyverse is it has that unifying feature or underlying philosophy to sort of be able to move across contexts. And so what I really mean by saying that it has unifying philosophy, unifying grammar, unifying features is that there are really important ideas that you'll find to be true in every single one of the Tidyverse packages. And so one of those is the Tibble, which is effectively a table or data frame. And so we'll get into that in a second. But I do want to quickly mention that you have quite a bit of play data sets that are preloaded in R, but also come with the Tidyverse to practice these skills. And so I'm going to sort of be throwing a bunch of different data sets at you. Throughout this, I'll be mentioning the names, and you'll notice that when you actually type those into the command line, like the name of those data sets, even if they're not in your environment on the right, they're already loaded for you. So just sort of don't panic when you see me playing with a data set that you don't have. You definitely have it, and it's going to be in your RStudio. To see the full list of data sets that you have, you can do library help equals data sets. So I'm going to run that, and it opens up this extra window. And so you'll see here on the left under index, these are all the names of the data sets. And then on the right, these are the descriptions. And all you have to do to access these is just type the name. So you'll notice over here on the right, I don't have a data set called CO2. But if I go down here and type CO2, I have a data set. So a bunch of different entries. There's 84 entries. We have our variable names up here. So all of these are already on your computer. If for whatever reason, you're having trouble accessing those, you can just type library datasets and then hit run, and then it will load all of them for you. Great. So now let's go ahead and hop into our sort of Tibbles crash course. And the first thing that I want to just make very explicit is that Tibble, while it's a sort of data structure that is underlying the Tidyverse, as we'll get into in a second, it's also a package. So if you load the Tidyverse, so say library Tidyverse, it'll be loaded for you. But if you only do something unrelated and you need Tibbles, you need to make sure you load the Tibble library. So Tibbles sound initially intimidating and confusing because it's a made-up word, but they're really just sort of contemporary versions of R's DataFrames. And so for anyone's general conceptualization of Tibbles, they're really just a table. And so, if you've ever used Excel before, you've used the same sort of functionality of the Tibble. The Tibble just has a couple of nicer features. And so to sort of build up an intuition about those, differences, right? We're going to compare the old version of a DataFrame in R, which is, again, very close to a table, and the Tibble, which, again, is a table with some different features. So the first thing I want to introduce you to is a data set we'll be working with for quite a while, so it's iris. And if we use this view parenthesis iris function here, it'll pop up to us just like an Excel format. So you'll see up here we have our column names, which are our variables, and then we have our indexes from 1 all the way down to 150. And then we have all of our respective entries. And we can sort of sort this just like an Excel sheet. So we can order, say if we wanted to order these lengths in column 1 from shortest to longest, we can go ahead and click this. And this is now sorted from shortest to longest, with index 14 being the shortest and index 132 being the longest. If we want to go back to the normal index, we can just click over here to sort by row names, and now we have back from 1 to 150. So this is just the viewer. You can't sort of change the data in here. You can't, do anything like go into this cell right here, 3.6, and change it to something else. But this is just a good way to sort of inspect your data. So we're going to go ahead and exit out of that. Great. So we're going to be working with that iris data frame. But now let's go ahead and compare a data frame to a Tibble. So first, iris itself is already, as it's loaded on your current computer, a data frame. So if we go ahead and run this, we get this result. And so we see this description here. The data frame is 150 rows by 5 columns, and we sort of see the same columns that we were just seeing. If we scroll down here and use this function, which I'll get into in just a second, as Tibble, we can go ahead and run this, and we see the same columns, 5 columns, 150 rows, and instead of data frame, it's going to say Tibble up here. Now, you might be thinking, well, they look exactly the same, and that's true only in R Markdown. And so because I'm using this is sort of a bug, so I'm going to have to move to the console to actually show you the differences. But R Markdown is created to sort of overcome the differences between Tibble and DataFrame to make it easier for you. And so as I sort of put here, the core R team tries to make things seamless, but in reality, they are actually different outside of R Markdown. So let's go ahead and type iris, the original data set, which is a data frame, into console, and then go ahead and hit enter. So what you see just happened, we have the data set being printed. It shows us every single row, all of our columns, all of our data entries, and things along those lines. So it's very basic. It just shows us all of our data, and that's all we have with the data frame. But if we use this command as Tibble, which is a function to change data frames into Tibbles, as we go down here and type that, we see something different. So up here, this was our old data frame, but now we have a couple of different features that are highly noticeable. So first, maybe the most visually obvious one is we're only getting the first 10 rows of our data. Whereas with the data frame, it printed everything. And so one of the sort of key differences here is that it doesn't print every single row. It just prints the first 10 by default. Or if you change sort of that entry, as I'll show you in a minute, you can go ahead and say like the first 20 or something along those lines. But this avoids the old problem of data frames, where if you had really large data sets, it might cause your RStudio to crash just because it shows every single row no matter what. And so this sort of keeps your data from crashing. It allows you to sort of work with it faster and things along those lines. Another key difference is it tells you the dimensions at the top top left specifically. And so we see here that there's 150 rows in 5 columns, which in a data frame, you would either have to literally look at your data to figure that out and scroll all the way down and see the bottom row, or you would have to use the dimension function, which is dim, type iris, and then hit enter, which then tells you 50 by 5. And so a Tibble just automatically does that for you and shows it in the top left. Another nice thing about sort of a Tibble is that it shows you the variable type in each column, which is not the case in the data frame. So up here, it's just the name and then the first entry. But here, it shows you that the first one is a double, 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 and a factor. And so a double is sort of just, a numerical object that has a decimal point, whereas, an integer is just, a solid number with no decimal point. And a factor is sort of similar to a string, which is like character or text in a data set. But we don't have to guess. It'll just sort of show us right at the top. And that's nice because if we go up here, there's nothing differentiating a number from a text in a data frame. So even though they are different, they appear to us to be unique. And so what we would need to do is if we wanted to figure out the data type of the first column, we would need to type of iris, $, and then, the actual name of the column and hit enter, and then it will tell us that it's a double. So it just saves us a couple of keystrokes basically and doesn't require us to sort of keep that in our head as we go along. Great. Now, something to note here is that it's really nice that Tibbles exist in the Tidyverse, and that's that common grammar across all of these packages. But most other packages use DataFrames. And so oftentimes you'll be moving back and forth between DataFrames and Tibbles. It's good to be aware of which one is which. And if you have a DataFrame, it's very easy to move it over. All you have to do is say as Tibble, and then save that in a new name. So if I wanted to overwrite the old dataset iris, you could just say iris equals as Tibble and then in parentheses iris, or you could save it as a new variable. So now I have both. So I have iris underscore Tibble and then iris. Great. So the other thing that I want you to sort of know is if you want to change the way that we're printing our Tibble, you're able to do that by sort of 2 extra commands. So we can say n rows that we want to show, and then width equals 2 for how many columns you want to show. Again, I just wanted to print this to demonstrate to you that in our Markdown, it has its own default setting. So this command does not work well in our Markdown. But if you go into in R script or in console, you are able to do that. So what I just showed here is print our iris Tibble. We want to show 30 rows. So now we're seeing 30 rows pop up. And then with infinite means we're going to show every single column. Great. So we've sort of moved back into our Markdown file here. And I also just want to quickly show you that these sort of assume that you already have a data frame all set up, which we'll get into in a minute. How do we actually set up a data frame and things along those lines? But you can also do it by hand. So start a Tibble just by creating your own data. And so all I'm showing you here is we have this Tibble function. So instead of as Tibble, we can just sort of declare that we want a Tibble. And then you can go ahead and put sort of the inputs in, row by row, column by column, etc. So here I'm going to call this TB for Tibble for short. Tibble function, open parenthesis. I'm going to hit enter, and it's going to automatically tab for us because it knows that that's the proper format here. And then I'm going to declare 3 variables: normal vals, poise vals, and then transformation. And so before I explain what these are, we're just going to run it and see if we can get an intuition here. So each of these sort of entries, so normal vals, which ends with a comment, poise vals, which ends with a comment, or a comma rather, and then a third row here, these translate into the 3 different columns. And so the variable name here, so normal vals, becomes the name of the column. Pos vals becomes the name of the column, and so forth, transformation. So it's really easy to sort of set up a Tibble just by declaring your name and then putting the actual values in right next to it. And so our norm, all this does here is it generates 5 random numbers from the normal distribution with a mean of 0 and a standard deviation of 1. So these are these 5 random values. The Poisson values, so if we do our Poisson, this is going to generate 5 random values from the Poisson distribution with a lambda value of 1, which is essentially the expected value of that distribution. And so we have them here. And then this transformation is just going to be column 1 raised to the 10th power and then added to the Poisson vals, which we get sort of these values here. And so all we have to do to print it is just type TB, just like we did before, so with Iris. And now we have our own Tibble, which again is just a table of information. And so the Tibble function, so turning those random vectors into an actual data frame, is very transparent in a way that DataFrame isn't. And so that's another reason we want to use Tibble over DataFrame. So DataFrame sort of transforms your data in a way that you might not always expect. And so strings will sort of be turned to factors. There's changes in variable names if they're not valid. So you can't sort of have names that break the rules of our syntax. It'll just change it on you and so forth. So there's a bunch of different things that if you're not careful, DataFrame will do if you sort of aren't aware of them. So Tibble will not do those things. It'll sort of warn you. And so I have quite a few examples here. So let's say, we sort of have a name that breaks our syntax. So we have column space 1, or we have colon, tilde, $, percentage sign. So all these random symbols, a number, you're not allowed to start a variable name with a number in R, or just making it a blank space. These would all turn errors in DataFrame, or it would assign a sort of a new name to it, such as x1, x2, x3, etc. But in a Tibble, you're actually able to name it that way. So we have column 1 with a space. We have these random symbols as the name of this column. We have this number, and we have this blank space as the name. And so the way that we can do that is just by having these little sort of quotes on the left and the right of this. And if we've done that, we can sort of name it whatever we want, which is not the case in DataFrame. So this is another sort of nice property of Tibbles. Great. So another way that Tibbles and DataFrames are different is in terms of how we actually subset values. And so I'm just going to be focusing on how you do this with Tibbles. So, we have 2 different tools. We have the $, which is familiar to a lot of us, and then we have these sort of double brackets, which is also probably familiar to many of us if you have worked with R for quite a long time. But they are very similar. In fact, they are you can get the same functionality out of them, and it's more of a preference thing for a lot of us, or if you're doing something with a really large data set and you're not trying to always call up the exact name of a column, you can sort of use the index of the column up here. But this is just 2 different examples that do the same thing. So TB is the name of our Tibble that we created, and then this with the double bracket and the number 1 in it is going to call up or subset the first column. Now, if we wanted to get the exact first column via the name, so if we scroll up and see that it's norm vals, you can go ahead and do the $, type norm vals, and see that they are the same here. So you can either do $, or the double bracket. Now, I just wanted to put this in here as an example of like a really basic unit test, but this is, a step where if you're subsetting your data, we're able to check and demonstrate to someone else that our function that we're intending to do is actually doing what we want it to do. So, for example, let's confirm that these two ways of subsetting are actually identical. And we can use the any function, or we actually use the all function, so I'll just change that right here, to make sure that that is indeed the case. And so we can say, is it true that every entry in this way of subsetting the tibble is exactly the same as this tibble? And so if this is true, which it is, we can sort of keep this in here and show that that is indeed working the way we want. If for some reason it's not, and it turns out false, we can go in and figure out what's going on. So it might be an indexing problem, or that we've gotten the name of the actual column wrong, or something along those lines. So lots of different ways that we can double check that, but it's a really basic test that goes a long way. So try to keep unit tests in mind as you go forward. Another thing that I want to point out, so something you've probably seen a lot with ggplot, if you're familiar with ggplot, is this idea of the pipe. And so all a pipe really does is you take a data set, you have this parenthesis, greater than sign, and then another parenthesis, and then that sort of filters that to all of the steps below. So if we're saying, oh, we want to work within the tibble, then we pipe it, then we know that everything after is sort of engaging with that specific data set. So we know to read that the sort of this normal vals is part of this tibble data set. The one thing that I want to show, though, is when we're piping with tibbles, you have to use this little period here, which is essentially like a wildcard, so similar to the asterisk and shell scripting and SQL and things along those lines. But as long as that's there, you're able to sort of pipe with tibbles just as you would expect. Cool. So that's sort of the core introduction of tibbles, but I do want to introduce you to two more things. So one, how do we rename columns and variables in sort of the Tidyverse through this tibble? And then in a second, I want to do an explicit comparison between tibbles and DataFrames, just so we have a really good idea of them. So renaming columns in Tidyverse is much easier than in base R, because there's actually a rename function here. And so let's say we wanted to rename a column in our iris dataset. So the first thing we'll do, we'll recall that the base dataset for iris is a DataFrame. So we're going to transform it into a tibble. We're going to save it in this form right here, iris tibble. And then this next line is going to print it. So we're going to see that in a second. And then, so I'm going to just pop that up first. So this is us just printing the data set right here. So this is iris tibble. Then the next line down here is we can just easily rename the function by saying rename. We're going to have an input, which is the data set we want to work with to rename a column. So in this case, iris tibble. And then the second command is the actual renaming. So we're going to say this is the new name. So I just have woohoo petals. And it's going to be set equal to the old name, which is petals.length. So it's this third column right here. And if we save that in the same data structure, iris tibble, when we print it again, which is shown here, we're going to see the new name right here. So if we expand this out, we're going to see the new name. And so you can do it just in one line with two inputs, the data set, and then in the second spot, the new name and the old name. Great. So it's very easy to do that. But I do want to sort of go through and do this little comparison here. So it's actually easier to see in this R script. But on the top here, we have a data frame that we've sort of built. And then on the bottom here is us interacting with the tibble. So let's go ahead and first look at the two different data frames in Tibble. So I'm going to print the data frame. All we have is two columns, something called ABC, and the second column called XYZ. There's one row, And in the first column, there's the number 1, and in the second column, there's the letter A. If we look at the tibble of the data frame, it's similar, but just with the extra characteristics. So we have ABC, XYZ, 1 row, and then the entry 1 in the first column, and then A in the second column. Cool. So here are some of the clear ways that tibbles are better than data frames, which are similar to what we've already discussed. So let's see what goes wrong when we say, df $X. So how we might type df $X, or what we might have meant to type is, A or something along those lines. So let's say it's a typo. But what DataFrames do is that it guesses what you're talking about. So maybe we did intend to do XYZ, but we only typed X. And it's going to go ahead and give us this input of A back. So it's assuming we did this. But what if we actually didn't mean to do that? What if we meant to type A, or we didn't mean to type anything like that at all? Well, then we run into a problem because we might have an error introduced when interacting with these data frames that might not pop up or be made aware to us. And then we might do an analysis on the data that we're not intending to do the analysis on. But with a tibble, it doesn't guess. So if we have the name of our data frame here, $X, and we run that line, it gives us this nice warning. So first it returns null. So it says that that doesn't exist. And then it gives us this warning that there's no column called X. And so instead of guessing, it's very transparent and tells us exactly what we need to know. Now, if we do the second command, so we have data frame bracket, comma, and then we have open quotes XYZ, it doesn't sort of confirm the column that you're talking about, and it doesn't show the data type. So again, this could be guessing. And so it gives us A, which may or may not be the right thing that we want back. But it essentially doesn't sort of indicate one way or another if that's what we're interested in. But if we do the same command with the tibble, it does. So it tells us the actual column that it's referring to, so XYZ right at the top, and then it confirms the value that it's returning, which is A. And so with the data frame, we did reference the correct column, but there's no way to check visually. But the tibble does that for us. And so it's the same exact thing with this next one. So ABC, XYZ, if we do the data frame, it's going to return these two back. But here it's going to confirm that it's a tibble. It's going to confirm that it's a double and a character and things along those lines. So it's just important to know that tibbles have these extra features for transparency in your data that data frames don't. But you will see both tibbles and data frames throughout your time engaging with R and data wrangling in general. So hopefully that gives you an idea of basically what a tibble is. It is relatively basic. It's just a table with nice features, but there are some distinct differences between that data structure and the more common data frame, which is found everywhere else in the R universe. Great. So in a second, we're going to be moving into importing data, specifically engaging with this new package called Reader, which is also in the Tidyverse.